Hey everyone. So we're working today with polynomials, moving on a little further than what we looked at last week, or earlier this week. Earlier this week we looked at just some basic ideas, definitions of polynomials, and evaluating polynomials, just plugging stuff in, plugging numbers in and getting numbers out. Well, now we're going to actually look at working with polynomials and looking at multiple polynomials at the same time. And so today, this first section, 12.5, we're going to be adding and subtracting polynomials. And there's really two key things to remember when adding and subtracting polynomials. The first one is to combine like terms. Okay, we're going to want to combine like terms. We've done this before, so it isn't going to be anything new, but maybe just in this context. So whenever you have two terms or three terms with the same variable part, we'll be able to combine their coefficients. The second thing to keep in mind is to distribute the minus when needed. In any of the subtraction problems, you're going to have to do a little bit of distributive property before you start combining your like terms. Okay, these are really the only two things to keep in mind. So let's look at some examples. Let's take an example of something like x squared plus 3x minus 7 and add that to 3x squared minus 5x plus 10. Alright, these are two different polynomials. The one on the left is degree 2, the one on the right is degree 2. They're both trinomials because they have three different terms. And so, again, the main idea here is to combine like terms and to distribute the minus when needed. Well, here we have a plus. And when we're adding two things, we don't really need to distribute. We can distribute the plus, but it doesn't do anything. It doesn't change anything. So we're really just looking to group together the like terms. So I'm going to write this out even though you don't necessarily need to. The x squared terms I'm going to put first. So I've got those two terms. Then I'll take the x term, so that's another 3x and a minus 5x. And then I'll take the two constants, so a minus 7 and a plus 10. Alright, so that gives us our 6 terms grouped together by degree. Second degree, first degree, 0 degree. And then we can combine the coefficients. So this is 1x squared and 3x squared makes 4x squared. 3x minus 5x is minus 2x, and negative 7 plus 10 will give me a plus 3. Okay, so again, we're just combining like terms. The end result should simply be a new polynomial. Okay. All right, let's take a look at another example. We'll just throw a few of these out here. Something like x minus 8 plus x to the third plus 4x squared minus 18. Again, we're just going to be looking to combine like terms. So anything with an x cubed, since I see that in here, I'm going to separate that off first. This is the only one. There's only one term like that. The x squared term, I'm going to separate that off, but again, it's the only one. The x term, I'm going to separate that off. It's positive, so I'm going to use a plus x. And it's the only term. And then the constants, well, there are two of those. One's minus 8 and one's minus 18. The first three terms are all unlike terms. I can't combine any of those with anything else, so I'm going to leave them alone. But the last two terms, the constants, will combine to give me a negative 26. Okay, so you've got to be very careful to combine like terms, but combine only the like terms. Don't combine things that shouldn't be combined. Okay, let's take a look at a couple of subtraction examples. I think the subtraction ones are a little bit trickier. You're going to see some things like x squared minus 5x minus 3x squared plus 7x plus 1. Okay, so here's where I said at the beginning we need to consider distributing the minus when needed. The reason for that is that in a subtraction problem, you've got a polynomial minus another polynomial. You're subtracting the entire polynomial, which means you're subtracting every term. So if you subtract a 3x squared, you would write minus 3x squared. If you're subtracting 7x, it's minus 7x. And if you're subtracting the 1, it's a minus 1. And so in a sense, you're distributing this minus to all three terms on its right. So if I rewrite this out using that idea, the first polynomial just stays the same. Then here I change all the signs. So this will be negative 3x squared, a negative 7x, and a negative 1 or minus 1. Then again we group our terms together. X squared minus 3x squared minus 5x minus 7x minus 1. So the first two terms add up to a negative 2x squared. The middle two add up to a minus 12x. And then you have the minus 1 that doesn't have a like term. Okay. Alright, and let's try one more subtraction problem. Maybe I'll make this one a tad bit more complicated. Something like 4x to the 5th minus 8x to the 3rd plus 7x squared minus 11x plus 2 minus, let's go 8x to the 5th plus 3x squared minus 9. Whoa, you can't even see that, can you? There it is. Looking at the paper, not the phone. Okay, so there's our polynomial, two polynomials. And here again, I'm going to distribute this minus to every term that follows it. So I really have 4x to the 5th minus 8x to the 3rd plus 7x squared minus 11x plus 2. I always rewrite that first one as is, and then write the second one with all the changed signs. So a negative 8x to the 5th, then negative times a positive is a negative 3x squared, and then negative times negative makes for a positive 9 or a plus 9. From there I group things together and add them up. And so I've got the 4x to the 5th minus 8x to the 5th. I've got a minus 8x to the 3rd. I've got a 7x squared minus 3x squared minus 11x, no other x's in there, plus 2 plus 9. So that should be all of the terms. Just double checking, make sure my count is right. It is. And then finally I'm going to combine all of the like terms. So this becomes a negative 4x to the 5th. Nothing to combine with the x to the 3rd. The x squares, this would be a plus 4x squared. The x is by itself, and the constants make up an 11. And that's it. Okay, so we're just combining like terms, distributing the minus whenever needed.